Let's take a look at this problem. We want to solve each polynomial equation by factoring and then using the zero product principle. That's the same as zero factor property, just different name for it. So we got 3x to the fourth is equal to 81x. Now the first thing is, for the zero factor property, you have to have 0 on one side. So I'm going to take the 81x over to the left side. The reason why I take it to that side is I want the numbers in front of our x to the largest power to be positive. So we got 3x to the fourth minus 81x equal to 0. Now once you get 0 on one side, you want to factor the other side. And the first method is GCF. They both have a 3 and an x in common. And that gives me x to the third minus 27 equals 0. Then the next method we'll use is difference of two cubes. This is two terms of minus unit, but difference of two squares doesn't work because nothing times self gives you 27. So we're going to try to write this as something to the third power minus something else to the third power. You ask yourself what times itself 3 times gives you whatever you're looking at. The x to the third, x times x times x gives us that. 27. 3 times 3 times 3 gives us 27. Now I'm going to label this as f, what's my first set of parentheses. I'll label this as L, what's my last set of parentheses. Remember our formula for difference of two cubes is f minus L times f squared plus fl plus L squared. Now the 3x just carries down. Everywhere there's an f in my formula, I'll plug in x, and everywhere there's an L, we'll plug in 3. So we got x minus 3 times x squared plus x times 3 plus 3 squared equal to 0. So we've got 3x times x minus 3. X squared, x times 3 is 3x. 3 squared is 9 equals 0. Now this doesn't factor down any further. So zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set 3x equal to 0 and x minus 3 equal to 0 and x squared plus 3x plus 9 equal to 0. Now on our first equation here, I divide both sides by 3. And 0 divided by 3 is 0. So that's our first answer. This one I'll take a negative 3 over, it becomes a positive 3. And that's our second answer. Now this equation we have to use the quadratic formula on. Quadratic formula says you have to have 0 on one side, which we do. Then we identify the a, b, and c. A is the numbers before x squared, which is the divisible 1 in this case. B is number before x, which is 3. And c is our number at the end, which is 9. Our quadratic formula says negative b plus or minus square root of b squared minus 4ac all over 2a. If you mess up on signs, it's probably a good idea to go through and put parentheses in everywhere you have a variable before you plug in your numbers. Everything else remains exactly the same. I'm just replacing the variables with parentheses. Now everywhere I had a b, I'll put in 3. Everywhere I had an a, I'll put in 1. And everywhere I had a c, I'll put in 9. So we get negative 3 plus or minus 3 squared is 9 minus 4 times 1 is 4 times 9 is 36 all over 2. 9 minus 36 is negative, what is that, 27? Yeah, negative 27 over 2. Whenever you can simplify your radicals, you should before you go on. Negative 27, that's negative 1 times 3 times 3 times 3. Now remember, with the square root, we're looking for a pair of somethings. Here's a pair of 3s, so those are going to come out as a single 3. And this negative 1 will come out as an I. So we're going to have negative 3 plus or minus 3i square root, and we're left with a single 3 inside, all over 2. Now whenever you have an imaginary part, you always want to split your real part separate from imaginary. So I'll put the negative 3 over 2 plus or minus 3 square root of 3 over 2 with an I to the side. And those are our other two answers. Plus or minus is why there's two answers there.